Everybody nowadays talks about vertical slice architecture. But what if vertical slice architecture is just glorified spaghetti code? Is this a possibility? Well, stay with me because in this video we'll deep dive into what vertical slice architecture is and we'll try to evaluate together and critically if vertical slice architecture is worth the effort. Hey there and welcome to the Code Wrinkles channel. Let's dive into this very interesting topic of software architecture, and I want to start by observing that usually people try to or tend to oppose actually clean architecture to vertical slice architecture. But are those two architectural types really different? To this question, we'll find an answer shortly in this video. But for now, I would like to get started with a very brief overview of clean architecture. And by the way, regarding clean architecture, I have already a lot of videos on this channel in the software architecture playlist. So I'll link the playlist in the description of this video, and you'll find also a link here in the corner upper right. So if you want to find out more, you should be able to go to that playlist and, well, go through it and see all the videos that might be of interest to you. When it comes to clean architecture, I guess everybody has this picture in mind. It's the most popular representation of clean architecture in concentric circles. Now we have the blue circle, the outermost circle, which contains the UI, the different frameworks that we might use, and the DB or database and other external services that we might actually want to talk to. Then we have this green circle where we usually have our controllers, if we think in terms of ASP.NET Core. Then the red circle, which contains the use cases, which is the application business rules. And then we have this yellow innermost circle, which is the entity circle. And if we follow domain-driven design, that would be the place where we would put our DDD stuff. This is very popular, and the most important aspect of this type of representation is that we need to be careful about how dependencies flow. And the rule here is that dependencies should also flow from the outermost layer to the innermost layer. That would translate into something like that. So we have here different layers. We have user interface, which could be also an ASP.NET Core project if we have an API. Then that project depends, of course, of the application layer, the use cases, and that application layer depends on the domain or the entities in terms of the clean architecture diagram that we have looked earlier. Now, the only problem comes in when we think about this infrastructure layer, and you see that I have placed this infrastructure layer basically outside of our layering of the application. And the reason for that is that, as said, infrastructure is just an outer concern, but the main flow or the business functionalities of our application can be represented in these three layers that we have here. Now, it just happens that some of those layers might use the infrastructure to get some data from the database, but logically, from the modeling of our application, everything happens basically here in this main part. Now, there is here a point of discussion because some people might say that the user interface or the API layer can depend on the infrastructure layer. Now, the confusion comes from the fact that when we think about ASP.NET Core projects, we would need to reference the infrastructure project in order to be able to add repositories or the DB context to the dependency injection container. And that's true. However, this is only a compile time dependency. Like, we need this package or this project reference to compile the entire solution, because otherwise we can't add it to the dependency injection container. But other than this, the API layer should never actually depend on the infrastructure layer, really never. Now, of course, the application layer would define interfaces that would be implemented, for instance, in the infrastructure layer, and therefore the infrastructure would depend directly on the application, also when it comes to the runtime. So, this being said, let's move on to the next part and try to understand exactly, okay, what are the problems that the vertical slice architecture tries to solve. Let's assume for this that we have an application that handles payments. Now, if we organize it by layers this way, we will probably end up having something like a class for payment, which would be in the domain layer. We would have a payment controller, which would be the UI or the API layer. Then we would have a payment service, which would be in the service layer or in the application use cases. And then we might also have a payment repository, which is, of course, in the infrastructure layer. Now, I have chosen this example with the services, like we have services in the use cases layer, because it's easier to understand what actually the problem is that vertical slice architecture tries to solve. Now, the main concern with organizing this code or the code this way is that we will end up in the end having a very big footprint of change. This means that if we would need to change something to our payment or to any functionality of the payment, we would need to come and look in the payment controller, then probably would have to also look in the payment service and then in the payment repository, and maybe we need to make some changes also in our payment class, which is part of our domain layer or entities. Now, the thing is that in the name of code reusability, we tend to reuse a lot of methods for different functionalities. And this is where the problem comes in, that if we do a change in the payment service or in the payment repository, we might affect actually functionalities that are not related to the functionality that we try to update in that specific or in this specific moment. Let's go one step further and understand exactly how that could translate to. Let's try to visualize this better with this basic example where we have two different functionality outlined here on different layers. So if we have a simple GET request, we will just use the payment service and GET and the payment repository. The same for edit. Everything is straightforward, with the only thing that when we edit, we just need to get it first and then we need to save that specific payment. And the same goes for create. We just create that payment and we save it and that's it. So everything is okay. Now let's go to the next functionality and let's assume that right now we also have, for instance, a finance authorizer that needs to authorize a certain payment, which by the way is an example extracted from a real application for a customer that I have worked on. Now, the problem is here that we have this finance controller, and that finance controller would probably use some finance service to get some info or to process some information regarding, well, what the finance user can do or what actions are available for finance users, for instance. And that would also use probably a finance repository to retrieve and store some data that are specific for these specific actions. And that's also okay if we just want to get some data, then everything is straightforward. Of course, when we want to discover some data here in the finance service, we might even want to find some information regarding the payment that we want to authorize or things similar to that. So we would also need the payment repository for that. Or we might even go to the payment service to get the information that we need. However, now comes the fun part, because when we want to authorize this, of course, we would have probably in the controller an action for that, and we would have in the finance service an action for that. And the finance service, once again, needs to get some data from the finance repository, but it also needs to get some data from this payment repository. Now, when we want to persist changes, like when we have authorized something, then first of all, we need to save something in the finance repository, but then we also need to save something with this payment repository. And once again, we could go to the payment service. The idea is the same. The problem is that here is where the shit hits the fan. Because here is when we try to reuse a lot of different functionality. That's the point when, for instance, when for the finance user, we say that, okay, saving something or after the authorization needs to be done a little bit differently than saving a payment after creation. So we go to the save method in the repository and try to update it with ifs or switch cases, whatever, so that we can make it work both with this payment service, but also with the finance service. And that's really the source of a lot of bugs. I would even dare to say 80% of bugs in the applications that are layered like this have this common problem as a source. And therefore, the thing is, what if instead of doing this and having all this very heavy layering, we could simply extract each functionality and make of it basically a functionality on its own. So we would have kind of like slicing of different functionalities that should be in a way atomic and should be self-contained, self-isolated, and self-sufficient. Therefore, we have this code structure or code organization that's prone to spaghetti code, and vertical slice architecture comes to solve this problem by extracting behavior in self-isolated and self-sufficient slices of functionality. Like this slice of cake here, for instance, where we see that, okay, we don't care about all the cake that we have, like is the entire application that's structured on different layers, but we care only about the things that we have in the current slice. So we can assume, for instance, that here on the top part, we have our API, like the controller that, or the controller action that's handling a certain request. And we have different layer that kind of like handles the things that it needs to handle. And you guessed the idea. So instead of focusing on the entire cake, we just focus on one piece of that, which is one functionality, and how do we implement that functionality using different classes that are meant to actually perform different actions. As it is always the case with marketing stuff, everything seems to be great and shiny. And that's where our critical thinking should come into place. Because what we tend to do when there's a new kid on the block is to throw all the old stuff at the trash bin and replace it with the new and shiny stuff. The new stuff, however, comes with its own challenges that we are not aware of mostly. Now, both traditional layers and vertical slice architecture have one thing in common, and that is organizing code trying to minimize coupling and to maximize cohesion. Traditional layers organize code horizontally by technical concerns, while vertical slice architecture organizes code, as we have seen, vertically by functional concerns. And that is the point where everything gets crazy with the vertical slice architecture, because most promoters of this type of architecture say, hey, forget about all the technical concerns, just organize code vertically by functionality. What can go wrong with that? But how would this look in practice, I would ask, and let me show you. Here's a random GitHub solution that is proposed as a template for vertical slice architecture. So let's take a look at it and see what do we have here. So first of all, we see that we have only two projects. We have a project for the API and one for the application. Now, if we take a look in the API project, we see that besides this program.cs and startup.cs that kind of like would show that is an older version of .NET, we have just this filters folder, and here we have an exception filter, I would assume. Yes, it's an exception filter, and basically that's it. So we don't have anything else in this API project right now. Cool, then I would assume probably everything else is in the application project. So let's open this application project and let's take a look at what we have here. Now we have here a folder common. I'm not really sure about what should we have or what should we expect from this common folder. So let's expand it, and we see that we have behaviors, probably behaviors like pipeline behaviors, which is correct. We have some exceptions. So then we have some interfaces that are defined here. Then we have some mappings. I assume there are some mapping profiles, which is indeed the case. So it also uses AutoMapper. Then we have this models folder when we have domain event notification. Okay, so we have notifications for domain events. We have a page list, and we have a result. Okay, so we have some models. So it's using the object result pattern probably, which is okay. Then we have security. I'd assume here are things regarding the authorization, and here we have the authorized attribute. And okay, so we have this authorized attribute. Interesting, cool. But then we have this API controller base, and we have this auditable entity, and a value object. Okay, well, what is a value object? So it kind of like defines what a value object is, implements equals. Not bad here from this point of view. So that's what we have in this common folder. Then we have an entities folder, and here we have probably, I would assume, the entities, which is a to-do item and a to-do list. Then we have this features folder, and that's basically where the vertical slice architecture kicks in. Here they say, okay, we want to organize our code according to vertical slices. So we have these to-do items first, and then we see that for each feature, I would say, action of the application, we have a dedicated class, like create to-do item. So let's dive into it. And in this create to-do item, we see that it's actually a class or a file that contains a bunch of different classes. Like it has this to-do item controller. So once again, it's a controller that contains just one single action, and that's basically it. Of course, it inherits the API controller. Here we'll probably have some behavior I would have expected, but no, we just, properties that we can then reuse in our other controllers that they inherit from API controller base, which is okay, not wrong with that. But we have only one controller action here, and then we have this create to do item command, and then we have this create to do item command validator, which uses Fluent validation to validate the command if it is okay. Then we have, once again, in the same file, create to do item command handler, like the handler for the command that we have above, and then we have also this to-do item created event, which is a domain event, oddly enough. So that's basically what we have in this feature. Now, from my point of view already, but this is really a matter of taste, is the problem that, okay, we have one file and we have placed everything in just one single file, no matter what concerns, everything is just in a single file. And Steve Smith actually called this on Twitter recently in a very nice way, like mouse wheel driven development. This is the urge or the drive for developers to have everything in one file so that the only thing I can do is scroll with my mouse wheel and find everything in that specific file. That's kind of like what we have here. Let's look right now into what are, from my point of view, the biggest problems with this setup. From my point of view, the first problem with this setup is that it uses one controller for each action or one controller for each functionality. And some might argue that this is actually very understandable and readable. But boy, does this come with a lot of practical challenges when you go outside the limited box of a demo template. Controllers are groups of different resources, and this means in turn that there are some valid concerns or reasons on why we need to treat everything that logically belongs to this certain group in a certain way and treat it as a whole. And some examples for this include, first of all, we might have some behavior that's in the controller that's based on or specific for a certain group of resources. And this would translate into the need of having something like a base controller for each different resource type. And that's hard to implement in a meaningful way in this setup. Then a second concern from my point of view is that this is a total nightmare when it comes to API versioning, which, by the way, is something that all real production applications should have, and unfortunately no demo template takes this into consideration. And then there's also a third reason. For instance, in real apps we would have controller-wide authorization policies and only add action-specific policies when those controller-wide policies are not enough and we need to actually override them in a certain way or add something to them. So how would you implement this in the current setup? You can't, or at least not really in a meaningful way. And if you tell me that having granularly implemented authorization policies is not something that makes the code more readable and easier to understand, well, you can definitely have this opinion, but in this case we are on terms of total disagreement. A second big problem with this setup is validation. Just look at this current validator. We have this create to-do item validator, and we have here some simple logic that validates our command and say that, hey, maximum length should be 200 and it shouldn't be empty. And that's okay. It's good to have command-wide validation, and that's for sure something that we have to take into consideration. However, I think it's too simplistic and not the way that we should usually think about validation in real production applications. You see, validation is not that easy as it seems from my point of view, and there are always a few questions that we should ask ourselves when it comes to validation. The first one would be, what do I want to validate? The second is, why do I need to validate? And the third one is, who is responsible to perform this validation? You see that I say that this approach in this current setup is very simplistic because in real applications we want to have the concept of validation scopes. For instance, we need to validate the request. This means just making sure that the information that comes into our applications from the outside world is in a form or in a format that we can accept and work on. Then the second part of the validation is the need to validate if the intended action makes sense in the broader context of our application. So how does a certain action affect the overall working on the application? That's also another point that needs to be subject to validation. And last but not least, we need to also validate according to our business rules if that action is actually allowed based on the business rules that we have. And you see, all of these different validation scopes have different answers to the questions that I have asked earlier. How would we be able to perform this in this current setup? Well, we can't really, or we can, but that would mean place everything or all our validation in this same create do item comment validation class, and this would in turn mess up or mix together all the answers to all the previous questions in just one single place. These are just a few but very important problems with this setup. Still, it's already enough and easy to see that just trashing the technical concerns and replacing them with a pure functional based organization is a recipe for disaster. And that's why, from my point of view at least, even if the idea of vertical sliced architecture is a very good one, implementing it this way makes it just a glorified spaghetti code. But is there still a way to achieve vertical slicing? Well, there is, and in my opinion, the best way to achieve vertical slicing is by harmonizing technical and functional concerns, so getting the best out of both worlds. Let me show you how this would look like in practice. Here is the refactored version of the exact same application. Before we dive into it, I want to make clear, however, that I have done the refactoring only taking into consideration the points that we wanted to discuss during this video. So there are a lot of things in the application that still would need a little bit of refactoring from my point of view, but at least we have everything that we need to understand how we can harmonize technical level concerns and functional concerns in the same application. So let's take a look at that. So first of all, let's take a look at this API layer. Now in this API layer, you see that kind of like we have some more folders right now, but what we have done mainly is to actually create this features folder. And in this feature folder, we see that we have created this API base controller or API controller base. So here we might put behavior that is specific, for instance, only or for all the controllers that we have in the application. And then to see how we can harmonize these functional and technical concerns, we have here two different folders like to-do items and to-do lists, which of course express functionality. But the way that those does express functionality is it kind of like represent functionality based on a certain resource in our API project. In this case, this is the resource to-do items. And therefore, in to-do items, we have first of all to-do items controller. And in this controller, we'll of course place all the actions that belong to this controller. And that's important because here we have full freedom to actually design this controller the way we want. We can extract here some common behavior, for instance, in private methods that should be used or that could be used by all the actions in the same controller. We could even set controller-wide filters, for instance, if we would like to do so. And we could also do granular authorization, like everything that I have mentioned previously, we can do in this setup. But this doesn't stop here, because then you see that we have, for instance, this create to-do item file, which is, of course, a functionality. So we have here a feature slice, we have this functionality. But what we have done here is we have extracted in this slice of functionality only things that concern the technical layer or the technical organization or the technical boundary that an API would define. And this is this very common request and response thing. So we get a request and we need to generate a response. Everything that related to these technical concerns belongs to the API. So in this case, for this create to do item, we have first of all the create to do item as a contract, which is very, very important from my point of view. And you see that here we have this list ID, this title ID, and then we have this create to do item comment, which allows us to easily kind of like create a comment from this create to do item. And then what we have here is, of course, the create to do item validator. And the scope of this validator is, of course, to validate the data that we ingress as an application from the outer world. So at this point, when we take into consideration this idea of request and response and what this technical boundary should be responsible for, we need to validate that the data is in a workable format. So here is also the answer to those three questions that I have mentioned earlier when it came to validation. But then we have this create items to do validation exception, because this is a custom exception that we might want to throw, for instance, if the validation is not correct. So you see that everything that relates to this functionality, but that kind of like belongs to this technical boundary, we have even placed it in the same file. Of course, we could place it, we could have different folders for each feature and then place each class in a folder. So once again, that's up to the preference of each of you. But the idea is that we still have here a vertical slicing, because everything that belongs to a certain functionality we have here, still we keep this freedom on the controller level to kind of like be very granular with the things that we want to apply only on the controller that belongs or that is responsible to handle a certain resource. And similarly, we have this get to do item with pagination. And here, once again, we have the same thing. Like we have the external contract, which in this case for our use is the query params. Then we have this query, like from the contract, we want to be able to generate a query. Then we have this to-do item, which is once again the external contract, but in this case, the response that we return from this list, which should be different from what we return from the domain or things similar to that. And here we have another method to, well, work with a paginated list and transform it to a paginated list of our contract. So you can see how we have extracted slices of functionality, but that belong to a certain technical boundary or to a certain technical concern. And there is no real way to mess up here different technical concerns in one single place. So if we go one step further, we go to the application layer. Now, if you take a look here, you see that the application layer looks way cleaner than it looked before that. Now, there is only thing that I didn't refactor because it doesn't really belong to the discussion that we have right now. And this is this idea of infrastructure where we have some file services and CSV exporter and things similar to that. So I would also move that probably in the infrastructure layer because that's not application level logic. But other than that, you see that we have some abstractions that we can fully define here in our application layer. We have in this common folder only kept the things that were or that belong to this application layer. And then we have once again these features. So, and if you take a look and if we make a comparison to these features here, see that we have to do items here, and then we have to do items here in the features in the application. And of course, the same way that we have in our API, like in the to-do items, we have then dedicated files for different functionalities. It's exactly the same thing that we have here. So we want the create to-do list item, no problem. Here is the vertical slice that belongs to this specific action and functionality, but that also belongs to this technical concern or technical boundary that we have in the application layer. So it means that what we define here is basically, once again, in the same file, I wanted to show that I don't really have necessarily something against the idea of putting everything in the same file. The only thing that I have something against putting everything in the same file that doesn't really belong together. So in this case, we see that we have the I request. So this is the command that we have. And here regarding, then we have the command handler. And here is the part of the other validation. And that's very, very important because I have talked about this idea of validation scopes. So in the API layer, we do a certain validation with a certain purpose, but in the application layer, which is a totally different technical concern, we want to validate from a totally different perspective. And here, even though I haven't really placed a validation here, you could even create a validator or you can just use an if. So it's really up to you. How do you want to perform the validation? But the main point here is that when we want to validate at the application level, there are once again those three questions. What do we validate? Now, we want to validate the request or the command actually that comes in. The important question is, why do we want to validate? And the reason why we want to validate here is because we need to make sure that processing this request will not have application-wide side effects. And that's only a thing that an application layer could validate because it's the only place that should know, for instance, if a certain action, if a certain command could have potentially negative side effects on the entire application. And therefore, for who should validate, of course, the handler or the application layer, because this is where the knowledge should be. And then once again, we perform some basic stuff, get things from the database, then, well, we dispatch even events. We can do this totally in the handler, and even this dispatch events method, it's still a private method here in the same class. But once again, we have the things that belong together, like the command and the command handler, really in the same place. And the same things goes, of course, for this get to do items with pagination query, where we have once again the get items with pagination query, which is the query, and we have the handler right next to it. Now, in the handler, in this case, since queries will not have application-wide side effects, there's no real need to validate here. So in this case, we simply won't validate. Once again, we have within this vertical slice, this of functionality, like getting queries, we have full freedom how we want to do things. So we don't need validation, no problem, we don't do validation. Now, let's go down some other layers. And for instance, in this infrastructure layer, here we have the DB context and the configuration. Really, there's not much to really take a look into. However, there are two other things that I want to show you. First of all, we have this domain. And in this domain, once again, here we cannot really organize our code by slices of functionality, but we can organize our code by aggregates. And by the way, this project was using some concepts from domain-driven design, and that's why while refactoring, I have kept those concepts, but I kept the implementation from the original author. So this means that we have here a to-do item aggregate. And here in this to-do item, well, of course, we have just this simple class, but once again, I don't really have a problem to put things together that belong together also from the point of view of the technical concern. So we have here this to-do item class, which is our, let's say, domain model, but then we have this to-do item completed event, which is domain event. We have this to-do item created event, and so on and so forth, and even this enum priority level. So this belongs together. This has functional cohesion because this functionality goes together, but it also or is totally decoupled, conceptually decoupled when it comes to the technical boundary that it belongs, because this is our domain and here should be the place for most of our domain logic. So once again, if we take a look here, let's say we have features, and here in the application, once again, we have features. You see that, okay, you have to look into different places, but here you have to do items. Here you have to do items, and here you have to do items. So when tracking down behavior or things that you want to do, even if these are in different projects, but still they are organized the same way. And I also have here the shared kernel, by the way, because there were some common data structure that clearly shouldn't be part of the application layer, how they were initially. Like we have this idea of value object with this implementation that was provided initially. Paged list could be something that belongs to the shared kernel. And by the way, I have used the name shared kernel because once again, the original author has used some DDD concepts. So I kept this in mind when I did the refactoring. And then what the domain event means, this is also something that would belong to the shared kernel because we might have different bounded contexts and all of them will use the concept of domain event. And it goes the same for this idea of auditable entity. From my point of view, this is still vertical slice architecture because it follows the common pattern, and for each request there is only one handler that handles it. So technically, each request represents just a slice of functionality. And if we modify something in one handler, it will have no side effects on other handlers. So we have a self-contained, self-isolated, and self-sufficient module. But the main point here is that we also harmonize the technical concerns with functional concerns, and this sets us really up to avoid spaghetti code, in my opinion. Last but not least, I would like to say that that's just a proposal, and what experience has showed me that gives kind of like good results. This is not a universal truth or something like that, so if you think that other approaches are better, then by all means use those approaches. Just be aware that each approach has its pros and its cons. I guess this covers it. So if you enjoyed this video, don't be shy and hit the thumbs up button. Also subscribe to this channel if you didn't do this already, because that would totally help and you don't really want to miss out on future content that comes on this channel on a regular basis. And if you have any question or anything to say, if you just want to get in touch and get a discussion going, don't be shy and head over to the comment section and just leave a comment and I will be more than happy to answer it. This being said, once again, thank you very much for watching, and until the next time, I wish you the very best.